Topics in post-harvest technology. Freezing injury of horticultural commodities. When plant tissues are frozen, ice develops between the cells, causing destruction of cell walls and cell membranes. Freeze damage may also occur in some plant tissues when vesicles butt off the cell membrane during freezing. As water moves from the cell into the intracellular space during freezing, the cell membrane contracts and convolutes, and small portions may butt off. When the tissues are subsequently thawed, if the budded vesicles cannot reintegrate with the cell membrane will swell and burst. As a result of freezing damage, thawed tissues often exhibit characteristic water soaking, may collapse, and may also exude cellular contents to their surroundings. Freezing damage is a very different phenomenon from chilling damage. Chilling damage results from a dysfunction of cellular metabolism due to cool, non-freezing temperatures. Here's a photo of some frozen horticultural products. You can see we have bananas, roses, spinach, apples, and navel oranges. They were all frozen at 0 degrees Fahrenheit. In this photo, we see frozen oranges on the left and frozen apples on the right. They're still frozen, so they are rock hard. Here's a frozen apple that has been thawed, and you can see all the liquid that is being exuded from the tissues. If you were able to squeeze this apple, it would feel quite soft. The thawed orange doesn't feel as soft as the thawed apple. The orange is more tolerant to freezing, but because it has been frozen, it's no longer marketable for retail sale. In Florida and in California, if oranges are frozen, they are sent to a juicer to be made into orange juice because the fruit will not hold up to retail shipping and marketing after being frozen. Here are frozen bananas. And here are the bananas after they've been thawed. The peel has turned a nice dark mahogany brown, and the pulp has become very soft and almost pudding-like. A photo of frozen spinach, which actually looks fairly good. However, after it's thawed, all those tissues have collapsed, and you can notice that the tissues have released a large amount of their cellular contents, the clear liquid indicated by the arrow, onto the tray. Here are frozen roses, and the roses after they've been thawed. Once again, the tissues have collapsed dramatically, and of course, the roses are a total loss. A frozen and thawed iceberg lettuce head. You can see the glistening on the surface and the darkness of the leaves. They're very soft and have collapsed. The head is unmarketable. Here are frozen russet potatoes. The skin is cracked because as the water in the potatoes froze, the ice expanded and caused the skin to split. After the potatoes have thawed, they release a lot of liquid that oxidizes to produce this brown liquid. The potatoes are soft, but not too soft. These potatoes could be eaten, but texturally and taste-wise, they're going to be inferior in quality compared to a fresh, non-frozen potato. Here are frozen cucumbers, and the same cucumbers that have been thawed. Please note the water soaking of the cucumber tissues and all the liquid that was released from the cucumbers when they were cut open. Freezing point. The freezing point of a commodity is related to its water and soluble solids contents. Soluble solids refers simply to all the sugars, starches, proteins, and minerals that are dissolved in the cytoplasmic fluid of a cell. One must determine the freezing point for each commodity. Here's a table showing the freezing points of select fruits and vegetables. You'll notice that for apples, which are only about 84% water, the freezing point is relatively low, 29.3 degrees Fahrenheit. When you look at lettuce, which is almost 95% water, The freezing point is 31.7 degrees Fahrenheit. Again, in general, the higher the soluble solids content of a commodity, the lower its freezing point. Here we have the same table, but with different commodities. Looking at oranges, notice it's 84.1% water and has a freezing point of 29.3 degrees Fahrenheit. In contrast, for tomatoes, which when ripe are 94.8% water, the freezing point is 31.7 degrees Fahrenheit. Summary points. Freezing injury is distinct from chilling injury, as freezing usually involves the formation of ice crystals which destroy plant cells and tissues. Chilling injury occurs at non-freezing temperatures and is the result of cellular metabolic dysfunction. Freezing injury and chilling injury are very different in appearance and are easy to distinguish from each other. Freezing often results in textural changes or tissue collapse, water soaking of tissues, and leakage from tissues. Freeze-damaged commodities are usually unsaleable and unusable.